Thanks for joining this session. We're here to talk about integrating Couchbase Cloud data with Confluent Cloud, and essentially, how we can integrate a NoSQL database with a hosted Kafka streaming service. My name is Tim Wong, and we'll introduce ourselves. And my co-presenter is Ram Dagne from Confluent. So our agenda today is we'll talk about who we are. We'll discuss a reference architecture about how the two technologies can integrate. And then Ram will get into some concepts of data at rest versus data in motion. And then we'll talk about how you can integrate Couchbase Cloud with Confluent Cloud today. And then afterwards, we'll provide some handy links to get started and on how to do this on your own. So who we are. I'm Tim Wong, since I'm currently talking. I'm a principal solutions engineer based in the San Francisco Bay Area. I've been at Couchbase for 6 years, and I've been in the industry longer than I care to admit, but I've been probably working on technology for over 25 years, and I had stints at companies like Oracle, Informatica, and I actually work with 20th century messaging technology at TIBCO. And I'd let Ram introduce himself.
Thank you, Tim. Ram Dagne, I'm solutions engineer working at Confluent. I'm based in Bay Area. I support large enterprise clients out of Bay Area. Prior to Confluent, I was with Couchbase, where I supported a lot of common clients that Tim is also working on. Very excited to do my talk at Couchbase Connect21.
Great, thanks, Ram. So, we're making a couple of general assumptions with this presentation that you're generally familiar with Couchbase's technology. But just to, quickly, kind of do a quick review, there are a lot of great sessions during Connect to actually go deeper in specific areas of Couchbase, like eventing and, Nickel and analytics. But again, Couchbase is a single data platform that, offers, the benefits of NoSQL technology as well as SQL. So again, as a developer, Couchbase is easy to use. We use SQL++. So if you know SQL, as most of us do in the industry, it's very easy to learn how to run queries within Couchbase. We're scale agnostic. Essentially, we're a shared nothing elastic architecture platform. So as you need to grow, just add additional nodes. And we allow you to isolate workloads. So I could dedicate nodes for specific functions. So I don't have my SQL queries affecting my key value fetches or loads. We have built-in data replication with the introduction of distributed systems. We introduce the notion of possible node failures. So Couchbase is designed for essentially surviving node outages in a distributed environment and with very little perceived downtime. We're location agnostic. So again, we can have data down to the user as far as a mobile device, an iOS, Android, Microsoft Windows device, to a edge data center, let's say a retail store, all the way to the cloud, let's say a major data center hosted in AWS. And we're deployment agnostic. And essentially we run in both cloud, bare metal, VM containers, specifically being orchestrated by Kubernetes. And so Couchbase, however you choose to cloud, is we'll talk about essentially deployment options with Couchbase. Upfront is with Couchbase is we offer Couchbase as a database-as-a-service. A lot of our clients don't want to manage a distributed database. They don't have resources. Maybe they're small companies. Maybe they're trying to move everything to a cloud provider, and they're used to having the cloud provider manage servers. So Couchbase Cloud offers both a hosted option, where essentially Couchbase hosts the entire environment, the VPC, for you. It's a single build, no guesswork, easy to deploy. It's really good for small, lower development environments, as well as for startup companies. And then VPCs for enterprise customers who want data security. They want to manage the data systems themselves. Essentially, they don't want to manage the individual Kubernetes containers running Couchbase, but they don't want a Couchbase personnel to be able to get access to that data. They can run within their own private VPC. The database as a service runs today on AWS, and Microsoft Azure support for GCP is forthcoming. And then for those customers, and traditionally Couchbase has worked with clients who run a self-managed database. And again, customers run us on public clouds. Some of our major accounts that are probably presenting here at Connect, like Amadeus, run a lot of their clusters on AWS. And they have the option to run on VMs on AWS, as well as Kubernetes containers. And then for some of our larger enterprise accounts, some financial services institutions, we run within their private cloud on-premise. Gives them maximum control, okay, and we run on both bare metal VM deployments as well as Kubernetes on-premise. So this is kind of a reference architecture between Couchbase and Confluent, and this is just an example, conceptual one. So you have kind of microservices servicing applications for end users on web applications or mobile devices. And on the mobile devices, I mentioned Couchbase Mobile. You have a footprint of the database on the mobile device that interacts with a sync gateway app server that then, based on security access, will update a backend Couchbase data center as needed. And essentially, as mutations occur in Couchbase, you may actually need to move that data to a backend system for operational analytics and BI, data warehousing, data lakes, and so forth. And how we do that is we expose because we have a mechanism called DCP, which essentially propagates changes within a Couchbase cluster. That's actually exposed to Kafka. And at the bottom layer here, we have Confluent, which is the enterprise Kafka platform, which will take mutations from Couchbase and populate backend systems that BI analytics type users might need. On the other side, you may actually have other data sources like edge devices, ERP, legacy mainframe systems that are doing updates that you need to propagate to Couchbase. So sometimes, a big common use case for Couchbase is to do mainframe offloads to essentially, if you process data on the mainframe, you pay the mainframe provider lots of money. If you move the data once to Couchbase, you could then do data processing or data servicing from Couchbase without actually incurring more mainframe costs. So that's an example of that. Those changes in the mainframe go to Kafka, then they get populated to Couchbase. So at the heart of integration with Confluent is the Couchbase Kafka connector. So, the key functional components here are the Confluent Cloud and the Couchbase Cloud platform, which is being rebranded during this event as Couchbase Capella. And the integration implementation is Couchbase Kafka connector. Essentially, we have developed a connector that plugs into Couchbase that allows changes out of Couchbase to propagate to Kafka. And then the integration framework that plugs into is the Confluent Kafka Connect interface. And we support different connector types, such as Couchbase can be a source as well as a sink, meaning a target destination for Kafka. So you can have Kafka topics populate a Couchbase cluster. And I'm going to turn this over to Ron.
Thank you so much, Tim. So a very brief introduction about Kafka. Kafka comes with 3 core APIs. One is PubSub API, is to just publish the data into a Kafka topic and then subscribe to those topics and then consume the data from those topics. It also supports Connect API, which is to create the zero code pipelines. So this Connect API, which is abstracted into a Connect framework, and that's what Couchbase connectors and all these other connectors that we support in fully managed fashion in Confluent Cloud, or some of the connectors are not fully onboarded into Confluent Cloud. And Couchbase connector is actually a self-managed connector, and we're going to see how it integrates with Confluent Cloud. So that is powered through Connect API. And at the heart of stream processing is a Kafka Streams API, where you'll be able to process these events that are coming into Kafka topic, process them in real time, and serve it out into two different systems directly, or create a materialized view into a topic. And then that topic can be read by some of the consumers, which could be, again, a sync connector or some other application. So taking a step back, as in what we see historically is that we have an application and we have a data store, and typically a data store is a database. So if an application writes the data into a database, the data is stored at rest. So that means every time if I have to query the state of my application, I have to fire a query at a database, and then I will get the state of my application. Now, this results into data is always at rest. If somebody wants to get the latest value, they need to fire a latest query, and then they can get the value out of that. So in this, the databases store the data at rest all the time. And if somebody wants to process the data, that data gets processed in a batched mode, mostly in the graveyard shift hours, like post midnight or nightly hours. So that means if somebody wants to realize the business value of that data, it typically happens on the next day, on next business day basis. But to change that paradigm, Confluent has introduced data in motion, and we will check that in further slides. So typically when if we take an example of a retail workloads, we see that we have data coming out of stores, we have retail ecosystem, and we have digital customers, and we have different applications. Those applications are backed up by different databases. We have data warehouses which are specific to store. And we see these systems which will connect, which will have point-to-point connections. And this kind of architecture can grow really brittle. They get overly complex. They're hard to maintain, hard to scale. So the key thing is that we don't want an architecture like this. We want a simplistic architecture where you will have ability to have all these different sources, ingest the data into this infinite buffer, which is Kafka, and then from there take this data out and give it to any target of your choice. So this is where data in motion comes into picture, where a customer wants to know what is the status of my order. They want to know what is the balance in my account. So if we have ability to process these events in real time, so at the end, the customer experience is getting better. So Kafka is built just for that, where real-time data processing is ubiquitous and it is continuous, and we really power that data in motion through Confluent. So the way the paradigm is shifting is that we could have this several microservices. That could be a sales microservice, shipment, trading, customer experience. So this data is trickling into Confluent, and data could be coming in real time or through in a batch mode. Data is persisted into Confluent into different topics, and this can be processed in real time via Kafka Streams API. We also have a notion of KSQL DB, which is abstraction of Kafka Streams API, and we have put a SQL-like interface to Kafka Streams API, and you can run these continuous queries on your data or events that are coming into Kafka topic, and you will be able to power this rich front-end customer experiences by say, for example, we can sync this data direct into Couchbase buckets. So we can use a Kafka sync connector. We can use a Couchbase sync connector for Kafka, and then we can egress this data out from a topic and give it to Couchbase bucket. And this could be any of the target system that you have. It could be your S3 bucket. It could be your blob storage. It could be your BigQuery table. So idea is that take the real-time events, real-time messages that are coming in, persist into Kafka topic, and give it to the target systems, which could be Couchbase. So the typical integration looks like this. We have a source. Here, source can be Couchbase. So we'll use a source connector. So that will source the data into a Kafka topic, and we can use Kafka Streams API to do the real-time stream processing, and we can create a materialized view of that data into a new topic if needed. And from there, we can egress that data out through, again, a connector, which is going to be sync connector this time, and landing the data into, say, for example, Couchbase bucket. So we can create this end-to-end pipeline where we are sourcing the data from a database, Couchbase, through a source connector into Kafka, doing a stream processing using KSQL DB, and egressing that data out from that new topic, if you will, through a Kafka sync connector into Couchbase bucket. And this entire end-to-end pipeline can be created with zero-code pipeline You don't have to write any code. You can just use a JSON config that is needed to to launch these connectors. So in this reference architecture or the integration, how this will work is that we have these events that are coming in from, say, IoT devices or from microservices or from systems. So all these events are coming in. If we are looking at the picture from left-hand side to right-hand side, they're getting processed into Couchbase buckets, which is hosted, say, for example, on Confluent Cloud. And if you have to, say, sync this data or we want to source this data to a Kafka cluster, so we could use a source connector to source the data from Couchbase database into Kafka topic. We can use source connector, and data again gets persisted into Kafka topic. And from there, or other way around, if you want to take the data from a Kafka topic, we create a materialized view, read the data from a Kafka topic, and push that data back into Couchbase for serving. You could use a sync connector, and then data will be egress from Kafka topic via the sync connector into a Couchbase bucket. Now here in this integration, as you see, the Confluent Cloud is a fully managed Kafka as a service. However, since this connector is not a fully managed connector on Confluent Cloud, so one has to use this self-hosted connect cluster nodes. Just two will do to start with, and then you host this connect worker nodes, whether they can be hosted on a VM. We also have a Confluent operator where you can deploy this in any Kubernetes service, whether it is on-prem or in the cloud. And then you can host this connect worker nodes and point them to the Kafka cluster running in Confluent Cloud. And then you can have the data egressed and ingressed into Couchbase running on Couchbase Cloud. So it's a very simple, high-level, like 10,000-foot overview of the integration between Couchbase and Confluent. Tim, you want to add something here?
Yeah, as Ram emphasized today, this solution requires you to self-manage a set of Kubernetes pods to run the Confluent Connect with the Couchbase connector to integrate with Confluent Cloud today. And what we'll do is one of the future exercises is Ram and I will work on publishing a public blog on how to set that up for those of you who want to play with it. And then long term, we'll get on the roadmap to have the Couchbase connector as a hosted connector within the Confluent environment.
Yeah. So the premise is that we have these different sources, we have these different targets. They all want to share data in real time. So idea is that as these events are getting generated, whether they are getting generated in real time or they're getting generated in a batch mode, so you need a system which can handle the velocity and the volume of that data, and that is Kafka. And Kafka works at really, really large scale, and really these cloud-first companies, even not just the cloud-first companies, but all enterprises, and they use Kafka to store those events into Kafka. And Confluent is the enterprise offering of Kafka. So you have all these events getting persisted, stored for any retention you want, and you can serve it out to any systems of your choice. So in one way, Kafka becomes this high-speed information highway with different on-ramps and off-ramps for you, and essentially becoming a central nervous system for the modern enterprise. And if somebody wants to consume, say, Confluent, we are platform agnostic, we are infrastructure agnostic. You can deploy on containers or bare metal, on-prem. We have fully managed cloud service, which is available on all 3 public clouds. So basically, you have a choice without compromise. And the deployments can span over from on-prem to cloud or vice versa. So you have absolute freedom of choosing to deploying Confluent anywhere.
As a follow-up, we'll actually post this during the broadcast of this session in the chat. But how to get started, there's information about the Confluent Connector Hub, a white paper, and then actual links to how to set up a Connect cluster on Kubernetes within your own Kubernetes environment locally. It can be on your laptop or home environment or office systems, and then some enablement links on the bottom for learning Confluent on the Confluent developer site. Then a second set of links, and we'll post this, is getting started tutorials on on how to integrate with the Kafka connector, and specifically just generically the Kafka connector. And then we have Couchbase Cloud documentation on that, and then Couchbase documentation on the Kafka connector itself. Then we have some blogs around the latest Kafka connector and what versions we support, and a blog written by Ram that shows you how to integrate both Couchbase and the Kafka connector, Confluent specifically, together as a solution.
Yeah, I just want to cover one point on the last slide. So let's just go back to the last slide. So this GitHub repo that I published here, it's actually available, publicly available. So yeah, just feel free to just use that. There are steps that one can just use, and they can do the integration by hosting a self-managed, whether it is a KSQL DB or Connect cluster, and then you can just point that to the Confluent Cloud, and it'll just work. So a lot of times, certain connectors, like say DB2 connectors or other legacy system connectors, are just not possible to be onboarded as a fully managed connectors. So there is always a need to have this. There is a fully managed Kafka service, but the connectors that somebody needs cannot be actually onboarded as a fully managed connectors. So in that way, we have created this publicly available GitHub repo where you can just use it. It has all the steps to how to deploy Confluent operator. We call it CFK. It's Confluent for Kubernetes. We deploy the operator, and on top of that, we will deploy Connect cluster, which talks to the fully managed Kafka service in Confluent Cloud. And I would highly recommend you to check out this developer.confluent.io website. It has a lot of material on how to write your applications smoothly on Kafka. Thanks, Tim.
No problem. Thank you very much for attending this session.